Hey everybody, in honors pre-calculus. Today we're going to be finishing up the notes from lesson 6.2 on verifying trig identities. And for this part, we are going to be starting with letter F from the notes that we started earlier this week. Just to remind you, we're going to be using these 5 strategies while we verify. And if you don't have these written down, it might be a good idea to find somewhere to write these. We're going to look for common factors. We're going to change all trig functions to sines and cosines. We're going to use common denominators to combine fractions that are added or subtracted. We'll start with the more complex side of the equation because it's easier to simplify than to make something more complicated. And finally, we might try multiplying by conjugate pairs. So we're going to keep coming back to those strategies. Also going to be frequently referencing the formula sheet. And as we have been doing the past several classes, we're only going to be looking at the first 3 sections of identities: reciprocal, quotient, and Pythagorean. So let's start with letter F. We want to verify that this side of the equation is equal to this side. And just like we have been doing for all of the other examples, we're going to start with one side and then slowly manipulate and adjust it until it looks like the other side. We're not going to treat this like a balanced equation where we can add something on both sides or subtract something from both sides. We're going to start with one side and stick with it until it looks like the other side. And honestly, I think for this one, the left and the right side are both equally complex. So I am going to choose to start with the left side here, although I think you could probably still start with the right side and still go places. But to start off, I'm just going to write the same problem right underneath just the left side, and we're going to get started. So what I am going to do first is multiply by a conjugate pair, right? We got to get rid of these 2 terms in the denominator somehow. It has to become one term. And I don't think we'll get there right away, but it's a good place to start. So I'm going to multiply by 1 minus cosecant of theta over 1 minus cosecant of theta. And I'm going to leave the numerator factored. And I'm going to multiply the denominator. The reason I'm going to multiply the denominator is because the denominator is where the conjugate pairs are. So I know if I FOIL, the outer and the inner will always cancel out if we have conjugate pairs. So we end up with 1 minus cosecant theta plus cosecant theta minus cosecant squared theta. And now the alarms are going off in my head because I have a 1 and a trig function that's squared. That makes me think of the Pythagorean identities. So I'm going to take a look over here. It's cosecant squared. That's this one. So let's see. I need to try to turn this into 1 minus cosecant squared of theta. So I'm going to think in my head of subtracting this cosecant squared to the left and then subtracting the cotangent squared to the right. And that'll give me 1 minus cosecant squared of u equals negative cotangent squared of u. So I have to put a negative in front of the cotangent squared. That's going to become my denominator. Okay. And then the cotangent squareds can cancel, right? So we'll be left with just negative 1 minus cosecant of theta. That negative is coming from the denominator. It didn't get canceled out, so it's still here. So I am going to distribute that negative just to make this a little bit nicer. So we'll end up with negative 1 plus cosecant theta. And I'm looking ahead now to the answer. And somehow I have to get a fraction back introduced here, right? I ended up with something that's maybe even a little bit simpler than the final answer. So we're going to have to do a little bit of work. I think we should try changing cosecant into 1 over sine. So I'm going to use that strategy where I change everything into sines and cosines. If I do that, I get negative 1 plus 1 over sine of theta. I did that again because I was looking ahead to the final answer and I see I need to get a denominator of sine. So there it is. All All right, now I'm going to multiply the -1 so that I can find a common denominator. So I'm going to end up with multiplying it by sine over sine. And so I get negative sine of theta over sine of theta plus 1 over sine of theta. And now I can combine these fractions. So I get negative sine of theta plus 1 over sine of theta. And that's so close to the final answer. I just have the terms on top switched around, but I want to try to make it look exactly like the final answer. So I'm going to write just 1 minus sine of theta over sine of theta. All I did was switch the order of the terms in the numerator, which I'm 100% allowed to do. But there we go. We got the final answer. All right. So there's a little bit of a trick in there, but makes sense. All right, let's keep going. Letter G. Let's verify that tangent x all raised to the 4th equals tangent squared x times secant squared x minus tangent squared x. So this time, the right side definitely looks more complicated to me than the left side. So I'm going to start with the right side here and try to manipulate it until I end up with the left side. So we're going to try to simplify. So I'm going to start by factoring out tangent squared. And I chose to do that. That was the first strategy that I wrote down, the first one that we did in the first lesson from this unit. If I factor out tangent squared x from this first term, I'm going to be left with secant squared x. And from the second term, if I factor out tangent squared x, I'm left with a 1. We can't forget that 1. It's like 5 divided by 5 is 1. The 1 still exists. Tangent squared x dividing out tangent squared x still leaves us with the 1. So that then is making those alarm bells go off in my head. I got secant squared x minus 1. If I take a look at my formula sheet in the Pythagorean identities section, if I subtract this 1 to the right side, I'm going to get secant squared u minus 1 equals tangent squared u, which is exactly what I wanted. So we end up with tangent squared x times tangent squared x. And then I can multiply those together, which means I'm going to add the exponents and I get tangent to the 4th, which is what we wanted. All right, if you start with the left side in this one, it's going to be a little bit more complicated. You're going to have to think through separating tangent squared x and tangent squared x, which just I don't think is really fully obvious logically. So it's a lot easier to start with the more complicated side and then try to simplify using our strategies. So let's try that again in letter H. We're going to verify that the left side equals the right side. And once again, I think personally that the right side looks a little bit more complicated. So we're going to start with the right side. And what I'm noticing here is that we want a sine x to be multiplied in our final answer. So I'm not too concerned that this sign is here. We also have a whole bunch of stuff going on right here. And there's 4 cosines in both of these terms that I can factor out. So that's what I'm going to do. I'm going to pull out cosine to the 4th of x. And I'm going to be left with 1 minus cosine squared x. And then this extra sine x is still tacked on to the end. All right, and now those alarms are going off in my head again. I have 1 minus cosine squared x, which is that first Pythagorean identity. So I should be able to subtract cosine squared to the other side, and I got 1 minus cosine squared of u equals sine squared of u. So I can change that whole parentheses to sine squared of x. And then when I multiply sine squared x and sine x, I get sine cubed x. And the last thing I'm going to do is just switch the order so that it looks the same exact layout as the way that the initial question was given. And then when I'm multiplying, I can switch the order and nothing bad happens. So that should be fine. So there we go. Check. We did it. All right, we're going to try one more question, letter I. Once again, the right side looks more complex, so we'll start with that. This one's going to be pretty similar to the one we just did, I think. We are going to once again leave this cosecant squared of x here because that's part of our final answer. I'm going to factor out one of the cotangents over here. And we end up with 1 plus cotangent squared of x left over inside the parentheses. And 1 plus cotangent squared, if I take a look at my identity sheet, is equal to cosecant squared of u. So that can change to cosecant squared of x. And everything else is going to stay the same. And now I can combine the cosecant squared and the cosecant squared to get cosecant to the 4th. And the cotangent's still here. And look at that, we already got it. We got the exact layout of the original question. So we got it. All right. So that is it. So thank you so much for watching. Hopefully that cleared some things up. If you didn't write down those strategies, I would backtrack this video and make sure you write those down. And we are going to spread out the practice for this lesson over a couple days in different contexts. So I hope by the end you'll have enough practice that you'll be a pro. All right. So thank you so much for watching. Have a great rest of the day. Let me know if you have any questions.